First problem, 236. A small rock is thrown vertically what? Upward. Okay. With a speed. So if it's thrown with a speed, this speed must be what? Final or initial? It must be initial. Okay. You don't know what the final speed yet. It could be zero. It could be positive. It could be negative, depending on if it's still going up, stopped, or went down. Of 80 meters per second from the edge of a roof. That is, sorry, of a 30-meter tall building. Okay. So what's the initial height of the throw? 30 meters. Okay, initial height. So apparently it was not thrown from the ground level. It was offset 30 meters above. Okay, and it was given a kick up 18 meters per second. Okay, the rock does not hit the building on the way back. Okay, so what does that mean? Look, it starts at 30, reaches definitely some kind of a what, max height, and then what starts? And apparently it doesn't hit the roof. So what's the eventual feed for it? It will actually what? Go all the way to the ground. That's basically what they're saying. Okay, and lands on the street below. Air resistance is what? Neglected. Every single time in this course, air drag is to be negligible. Okay, there's a famous phrase in physics: friction is negligible. Okay, but especially air drag, not friction. Friction we're gonna be dealing a lot with. We dealt with friction so much in grade 11. Imagine how much we're gonna do in grade 12. So question A: what's the speed of the rock? What? Just before it hits the street. By the way, Um, I used to always say what I think in my first year of teaching 12 years ago. What's the landing speed, or what's the speed when it hits the what? When it hits the street or the ground. When it hits the ground, what's the speed? Zero. And it was amazing. My first time putting that question, it was a test question, and so many people just wrote what? I had to give them full marks because technically it is the correct answer. But what do you think I actually meant? I actually meant what? Just before or immediately before what, touching the ground. Otherwise, where's the interesting aspect of physics? If everything goes to zero, yeah, we know it goes to zero. But how about the impact right before that? Okay, all right. So let's sketch a diagram. So here is the diagram. Okay, so I guess we need. Let me zoom out a little bit. Okay, so we need some kind of a ground. So here it is, and I guess this would be the building. Okay, where was the ball initially launched from? Which level? Ground or height of the building? Height of the building. So that means we know this is 30 for sure. We know this is 30 meters. Okay. So apparently it started from here with some speed like this, went up, reached some max height. We have no idea what it is yet. And then went all the way down right before touching the ground. There we go. That's how easy and simple and basic your diagram should always be. Okay, here's a question, everyone. What should be the positive direction in this problem? Up or down? Remember, both answers are correct, but which one do you think would be wiser for us to choose? Up or down? Josh, up. Why? Uh-huh. Then what? Then like that. Okay. But as far as just directionality, regardless of what's the minimum or maximum level allowed, why did you choose up? Yes. So initially, what was the motion? Where was the motion going? Up. Also another counter argument would be, but for most of the other motion, it's going what? So it doesn't really matter, right? Even if it was going up all the time, you still can take what to be positive? Down. But since it started positive, sorry, it started up, let's take positive to be what? To be up. Okay. So everyone, just here, I guess somewhere here, just write a vector pointing up and put positive on it. Okay. So far, so good. So that makes the 18 meters per second what? Negative velocity or positive velocity? The 18 meters per second. It would be positive because the 18 is pointing this way, and we said anything in the problem pointing this way will be what? Will be positive. Okay. So we're just gonna write 18 meters. per second here. Okay. Gravity acceleration always points what? Up or down? Always what? Always down. So that means for this stage, it will be what? Positive or negative? No, no. So acceleration of gravity physically points what? Down. And we said we're going to take positive to be pointing what? Up. So gravity acceleration here is pointing what? Down. So it must be what? Negative. Also here, it's also what? Negative as well. So acceleration, according to our positive designation, is negative all the time. Okay? What if I chose this strip to be pointing positive this way and this strip to be pointing positive this way down? Then for the second trip, acceleration will be taken to be what? Positive. Do you see what I mean? You can always change, everyone, for distinct trips, you can change the what? You can change the what? The positive direction. It's completely up to you. Okay? All right, let's focus on the first trip. So what do we know about the first trip? Initial speed of 18. What's the final speed of the first trip? The final speed of the first trip. Yeah, it had to come to a stop. So go ahead here and put, sorry, go ahead here and put 0. Yeah. Yep. Um, 0 here, 0 meters per second. And what are we going to put here? Positive 9.8 or negative 9.8? Again? Negative, because it's decelerating and it's pointing against what we said will be positive. So go ahead, negative 9.8 meters. Yep, Jinan. Go ahead. Okay. Okay, I can give you two arguments. First of all, when you kick something up, once it leaves your foot, is it speeding up or slowing down? Once it leaves, it's what? No, no. Once it leaves your foot, like once it leaves, what's happening to anything once you throw it up? Does it speed up or slow down? Once it leaves your hand, slows down. When something slows down, is it accelerating or decelerating? Decelerating means what? Negative acceleration. That's one way. The other way, okay, wait. The other way is I said anything pointing up is what? You just said that acceleration is pointing what? Down. So that's another proof that's what? Negative. Okay, so that's why. So you could have it as a physical argument or as a what? Vector argument. Okay, do we have three numbers about the first trip? Okay, all right. Now, how about the second trip? What's the initial speed of the second trip? Okay, so we have 0 here. Again. Okay, we are still going with what as positive? Up, which means here, negative 9.8. Not because it's decelerating, because it's accelerating which way? Down. Okay, please make sure you understand this. Not every time you have negative acceleration, it means what? Slows down. Sometimes it means it's because it's pointing down. Okay. Do I know any other numbers about the last trip? Think. Oh, 30 meters. Is it the distance of the full second trip or just a part of it? Oh, crap. I don't know what. We don't know the full distance. Okay. So we don't know the full distance of the what? Of the second trip. We only know the initial speed. We only know the acceleration. We don't know the final speed. Also, we don't know the what? We don't know the time, right? We do not know the time. So I can't really figure out the second trip then. So what do I need to know first about the first trip? Uh, Time or distance would be better, right? Because then, everyone, I can get this distance and then do what with these two distances? Add them up, and now I have what? I have the entire second trip. Okay, so let's do that. So for part A, let's find, go ahead, right, let's find max height. Okay, let's find it. So VI is 18 meters, or just 18. It's good for a unit. Acceleration is negative 9.8. And VF is 0. And delta D is question mark. What's missing from this list? The what? The time. Which equation has no time? Okay, let's apply equation number 5. Let's see. Equation number 5. Oops, sorry. V F squared equals V I squared plus 2A delta D. Okay. What's the final speed? 0 squared. Initial speed is 18 squared plus 2 negative 9.8 delta D. Okay. 0 equals, what's 18 squared? 324. 324. 2 times negative, sorry, plus times the negative, it means negative, and doubled 9.8 is 19.6 delta D. Great. So delta D is going to be the division. Well, you have to move something first. So I'm going to do it in one shot, everyone. I'm gonna assume I move this one here, so it becomes what? Positive, and then divide 324 by 19.6. Okay, let's do that. 324 divided by 19.6. What's the situation? 3. All right. So 16.53. Although this is technically an intermediate step, so we can actually we can take a fourth digit. So 16.53. Let's say 16.53 meters. Here's my question to you: is this above the ground or above the sea, the roof? How many people say it's above the roof? Of course, it's above the roof. By the way, what's illogical about this being above the ground? Exactly. It already started with how much above the ground? So it has to be something above 30. It can't be 16.53. It's from this reference. Nice. So the delta D, or the full distance, would be that plus that. Okay. So now let's what? Let's find VF of which strip now? Strip what? Strip. That's the whole point. The whole point of the question is, what's the final speed of the landing trip, not the ascending trip of trip 2. So let's just write trip 2. Okay. Everyone? What do I know now about trip 2? I know distance, which is the combination of these two. What else do I know? Initial speed, which is 0. Acceleration is negative 19.8. Only negative because it's pointing down, not because it's speeding, and not because it's slowing down. All right. So Vi equals 0. Delta D. Okay, I have a question for you now. Which way is it moving in trip 2? Down. We just said that anything pointing down should be given what sign? Nice. Yes. Otherwise, you're going to get what? You're not going to get the right answer for the final speed. Okay, everyone? Again, just because it's moving down, that means it has to be given what sign? Negative. Yes. So this has to be what? Negative how much? So what's 30 plus 16.53? Well, 46 point. I know. Yes. How many people are not feeling so easy with this? Seriously, raise your hand. I didn't my first time I saw this. You know what justifies it? Question for you. What's this? This is a symbol for what? No, no. Right now, it's what? Right now, this is the symbol for what? No, no. Distance. That's my point. But it used to be what originally? Could displacements, could vectors have negatives in them? Yes, because they could point up or down. That's why this could have a what? Remember, they could have negatives because originally they were not scalars. They were originally what? They were originally vectors. Direction matters. And that's why we designate what? Positive and negative. Is that making sense a little bit now? Okay. How many people are feeling uneasy because I'm saying distance is negative? That's the whole point, right? But I just told you, this is not really distance. This is actually what? Displacement. And displacements and velocities and accelerations are originally what? Scalars or vectors? Vectors. And vectors could be what? because they could point either positively or there's not, by the way, there's nothing negative about displacement. It's just the directionality of it because direction always matters, up, down, and so on. So always now, from now on, whatever you designate as positive, anything that used to be a vector might have what next to it? A negative, even though you understand it as distance, even though you might need to understand as distance at the end. Okay, so that's totally fine. Yes. If you okay, what if we designated a positive direction for the second trip? This would just be what? How many people understand this now? If we chose that positive should point up for the first trip and positive should point down for the second trip, how many people want to do that? To actually make sure that this one ends up being what? No, ends up being. Go ahead, do it. I really, I would not tell you what directions to put as positive or negative. You want to split the what? You want to split the problem into how many problems? Two, one with its own direction positive and one with another direction positive. Please go ahead. No problem with me. Whatever makes you understand. Yes. For what? For the second trip? Oh, okay, for the whole thing. Then, yes, the acceleration will also become positive. Is it making sense now? You always have to run every vector in the problem against what? Against what? The positive, negative designation you choose. Is that making sense now? So that's why, you know me, I'm going to completely leave it up to you. I trust that you will always what? Understand what to do and then choose the right decision. Yes. Uh-huh. No, but okay, listen up. Shira, just one second. You said velocity needs to be positive, not velocity. Speed needs to be positive. Velocity could be what? Positive or if I do positive down, positive or negative up. Velocity will give you a direction, a sign that tells you which direction it's going. That's why. Okay. All right. So everyone, let's put negative here, and let's take out the arrow from here. Okay. What else do I know? Come on. I know VI. I know displacement or distance. What's the last thing? Acceleration. And according to this, acceleration is pointing also what? Negative. Yes, you got it. So, yeah, go ahead. Okay. I have a question for you. Is gravity ever pointing up? So that means what? If we designate positive to be up, gravity is always going to be negative. But just because of the physical direction of gravity. Oh, if you choose this to be positive. That's why. Yep. Yeah. By the way, everyone, just so you know, listen up. Actually, everyone, Eric, just focus. If you actually, when I post my solutions for all these university problems, last year I used to split my problem into how many problems? So you'll actually see that one trip has one positive direction, and another trip has what? Another positive. But I'm gonna get the exact same answer. Okay, so that's good. You see it on the video one way, you see it in the solutions one way. Okay, so negative 9.8. Okay, what are we trying to find? V. What's missing from this? Time. So which equation again? Which equation? Also, what's the good news about this? All the numbers you need, VI, delta D, and acceleration, are already on which side of the equation? There no algebra, just plug it in. All right, let's do this. VF squared equals VI squared plus 2A delta D. And because there's no algebra, I'm going to go on the same line. I'm going to keep doing equals until I'm done. What's the initial speed? Good, 0 plus 2. Okay, everyone, question. Just hold on for 10 seconds. What's the sign for acceleration? What's the sign for displacement? What's negative times a negative? Which means, am I going to be able to take a square root? What if I did not put a negative for one of these? What would happen? The math would tell me, oops, you can't. Do you see what I mean? Everything, math and physics, at the end of the day, are one consistent structure. They have to agree together. Perfect. So 2, negative 9.8, negative what? 46.53. So that implies that VF equals the square root of, well, whatever we get here. Ooh. Okay. Obviously, I'm not going to put negatives because I already know they canceled each other. So 2 times 9.8 times 46.53. 911, 988, or 998, 988. All right. What's the square root? Where is it? 30 point. What's the sigma situation? 3. So that would be 30 point. Cut here, 2. Meters per second squared or just second? Okay, so it hits the ground at a speed of, by the way, does that make sense? Everyone, look at the diagram. Just hold on for, does it make sense for the hitting speed to be 30 meters per second? Look at the diagram. I want you to trace the diagram. What was the initial kicking speed? Kicking speed, 18. What happens to the speed as it goes up? What do you get the speed right here? Then what happens? Speeds up. Right when it passes by the roof again, what speed does it come back to? Do you see what I mean? It's a perfect what? It's a by the way, is there any air drag in this problem? Which means what? Air is not stealing any energy from it, right? Which means whatever it had at the beginning, it's going to come back to what? To the same thing. So what's the speed right here? And what's going to happen to the speed for 30 extra meters? Slow down or speed up or stay the same? Speed up, yep, to 30 meters per second. So logically, it does make sense. That's all. Okay? All right. Oh, okay, everyone. How many people can think of an easier way to have done all this? I'll give you a hint. Can you do this problem without even considering the up, down trip up to the level again, up to the ceiling again? I'll give you a hint. Consider how we traced it right now. How many people see what I'm talking about? Saad, what do you think? Tell me, Saad, tell me, what do you know about the trip from here down to here? From here down to here. The initial velocity right here is back to what? Say again? So he said negative 18. Or you could choose what? You could choose positive 18 if you chose your positive to be down, right? Okay, but at least it's 18. Keep going. That's one number down. No, final velocity is not zero because it hasn't touched yet. Don't fall into that trap. Remember, we have not touched yet. Saad gave us one number, 18. Noura, give me another number. I know exactly how much it's going to go through. 30 meters. Nice. One more, Ammar. Acceleration, which is either negative 9.8 if you're still sticking with this, or do you see how we could have completely circumvented this part? We would still get how much? 30.2 meters per second. Is it making sense now? There are so many ways to do any kinematic problem. Good. Honestly, if you want homework practice, do it that way. Make sure you get the exact same answer. Okay, what's part B? Part B is what? How much time? What does elapse mean? Pass by, go through, pass. From when the rock is thrown until it hits the what? So one trip or both trips? Both trips. Okay. So we have to have how many times? 2 times. All right. Oops, my bad. Okay, part B, everyone. Part B. Okay, trip number 1. Can I calculate the time? Of course I can. I know 18, I know 0, I know negative 0.8. What's missing from that list? What is not needed at all for trip number 1 now? Distance. I don't need the distance. So which equation has no distance? Has no distance in it. Equation 1, the definition of acceleration. So go ahead, everyone. Let's write. Trip 1. Trip 1. Vi equals 18 Vf equals stop, which is 0. Not distance. What did we say? Acceleration. Yes. Acceleration is negative 9.8. Delta time is question mark. Okay. As Kenda said, A equals a very quick, simple equation. Vf Vi delta t. What's my acceleration? Negative 9.8. And we are cross multiplication experts now, so we know it's going to happen. I put the 1. What's Vf? Vf is 0. Minus 18 over delta t. Nice. Minus will cancel the minus when you crisscross, which is correct because delta t always have to come out negative. Sorry, positive. Time always moves forward. So delta t equals, if you crisscross and then divide, you really just need to divide 18 by what? 9.8. So slightly less than 2 seconds. 1.84, I guess. Yeah, 1.84. Okay. Trip 2. Trip 2. Hey, let's do trip 2 Saad's way, which is what? Purely look at the what? The 3 numbers. So we're going to look at 18. We're going to look at 9.8. And we're going to look at 30. All right. So VI is, okay. Saad, should VI be 18 or negative 18? According to this designated positive direction we already chose. Again, but it's going negative 18. Acceleration. Also what? Negative 9.8. What's there? Distance. Also what? 30 or negative 30? Which way it's moving? Negative. You see, all of them are negative. Just because all of them are pointing down. And because we chose positive to be negative. So chose positive to be up, I mean. Delta D. Let me just squeeze these. Equals negative 30. And we need delta time. Hey, what's missing from this list? Again? Final velocity. Which equation has no final velocity in it? Again? Yes, third equation. Thank you. So everyone, delta D equals Vi delta T plus, yep, and go ahead. Yeah, okay, everyone. I had to saying for that trip too, could you have used the final velocity? Could you? You know it, so you could. Should you? Why not? Because it's what it was rounded. That's all. I will give you full physics marks if you do that, but I will still circle and comment. Okay. How do we do this? Yeah, well, who sees a problem with this? Wadah, go ahead. Go ahead. Okay, because in that trip, everything is going down. The speed is the velocity is going down. The displacement is going down, and the acceleration is pointing down. Acceleration does not go; it points. Say again. Yeah, but I'm talking about how is it moving within that trip? It's moving down. And what did we designate as positive? Up. No, up. Yeah, I'm still going with the old designation. Yeah, exactly. Yes. Yeah. Oh, okay, everyone. Wadah is asking me, why are you only measuring the time for that? Because I could double this time, right? That's all. Oh, sorry, I forgot to mention that. I could take this time and multiply it by what? Why? Because it takes as much time to go up, as much time to go what? To the same level. To the same level. Okay. What's interesting about this equation? It's gonna end up being a what kind of equation? Grade 11, grade 12, got a square part in it, starts with a q, quadratic equation. So this will be this. Negative 30 equals, what's the time? Oh, we didn't know it. But what's the VI? Negative 18 delta t plus half with a minus, so negative 4.9. 4.9 what? Uh, delta t squared. What do you need to use to solve a quadratic equation? There are only two ways to do quadratic equation. Either what starts with f, factor. Do you really want to factor this? No, because of two reasons. First of all, it's got decimals. Now, you might multiply everything by 10 to get rid of the decimal, but this will be 300, this will be 180, this will be 49. Do you think those numbers are going to factor? I highly doubt so. So what should we use? What's the big, big guns approach? Quadratic formula. Quadratic formula. So I'll leave it up to you. Okay? But okay, everyone, before you do quadratic formula, what do you need to do to the equation? You need to what? You need to what? Rearrange such that how is it always written? What term do you start with? The constant, the linear, or the quadratic? The quadratic. Then what follows? The linear. Then what follows? So that means what? I think I should move this guy here. So it becomes what? And I should move this guy here. It also becomes what? Do I even touch this term? No. And then since you moved these two here, what remains here? Nothing, which is what? 0. By the way, quadratic equations, you have to make it equal to what first? So you cannot use the quadratic formula until everything is shoved on the same side. So this is 4.9 delta t squared plus 18 delta t minus what? 30 equals 0. Again? 1 second. Oh, it's minus 30 because all of them are minus here. It's minus 30 because it was going down against what we designated as positive. I'm just plugging in numbers here. And because I didn't move it, I just moved these two. Yeah, I moved the other one. I would rather move everything to the left, especially if it gains a plus. By the way, just so you know, I do know that some of you probably have the calculators that has the, how many people have the calculators that could actually do the quadratic equation in them? The Sharps or the Casios with the double displays? Anyone? I think some of you might. If you have it, I'm not going to take marks off if you just plug in the coefficients and then go straight to the answer. If you actually want to do the quadratic formula, I definitely can provide it, or you can look it up and then just get the answer. Okay? And then what do you do with all the times? What do you do with all the times to get the total time? Add them up. So 1.84 this way, 1.84 this way, and then whatever quadratic time we get from that, you add the 3 times. Okay, all right, let's stop there because obviously this is just mechanical work, and let's go to another problem. Yes, please. What's the quadratic formula? Who remembers it? Anyone? X equals, obviously, does it always have to be X? No, it's just because usually the variable is X. Equals long fraction. What does it start with? Negative b. The b being what? The first, second, or third coefficient? Second coefficient. And then what? Plus or, because it's a quadratic, potentially it could hit twice, right? Square root, long square root. What's inside? B squared. Make sure this thing ends up being positive. So if it's a negative, put it in a bracket. Minus, no, 4ac. That's called the discriminant, right? That tells you if you have no solutions, one solution, or two. If it's negative, no solutions because you have imaginary numbers. If it's 0, you have what? If it's 2, you have what? So if it's bigger, you have 2 because you have plus minus. Yep. What's here? 2a. Everyone, the biggest mistake that people do and math teachers hate is they only show this. And then what do they end up doing? Only dividing the minus b by the what? By the 2a, not the whole thing. You see what I mean? You have got to make sure that your square root covers those terms and that your fraction covers the entire thing. This is the quadratic formula. And then you plug in and you just do very calm, collected bed mass until you get how many answers? How many answers? Two. If one of the answers is negative and one of the answers is positive, obviously, which one do you always take? Because time never goes what? It always goes forward, which means the delta is always positive. Okay? Yes. Sure. Okay, let's just do it. And last 5 minutes, I'll definitely go around and help people with their calculators and with doing this as well. Okay, let's just get one problem done for the rest of the period. Okay. Okay, question 2. Come on, everyone. Forget about what we just finished. Let's focus on this. You throw a globe of putty, which is basically just, a little piece of, like a ball, straight up towards the ceiling, which is what? Which is what? 3.6 meters above the point where the putty what? Leaves your hand. So it's kind of like, again, the ceiling and the launch point. The initial speed of the putty as it leaves your hand is 9.5 meters per second, about 35 kilometers per hour. Not too shabby actually. What's the speed of the putty just before it hits the ceiling? Obviously, what's the speed when it hits the ceiling? Zero. Everything comes to a stop with a very, very small time. Well, right before it actually touches. Okay? So what do we know about this trip, the upward trip? What's the initial speed? 9.5. Going what? Going up. Obviously, now we should choose which direction to be positive. Up. Okay. So the initial speed is how much? 9.5. Once it leaves your hand, once it leaves your hand, it doesn't have a propeller on its own. Is it going to speed up or slow down? So what's the acceleration, even as a physical magnitude? Negative. Okay, got two numbers down. How far is it going to travel before touching the ceiling? 3.6. Also, is it traveling up or traveling down? So it's a positive displacement. You got it. All right, let's do the first. Okay, so everyone, let's do a quick diagram. So here's the ceiling, and here's the launch point, and here is the what? Now, do we know? By the way, potentially, could it come to a stop as it touches the ceiling? Yeah, you could have perfectly calibrated your push such that it didn't need the ceiling to come to a what? It could have actually already come to a stop just at the level of the ceiling. Okay, and because I didn't know that, I cannot claim that here it's a stop or still what? Or still some wind effect motion. So you know what? We'll just leave it as is. All right. Let's put some numbers. So let's put the direction. Positive is up. Okay. How much is this? 3.60 meters. Initial speed is 9.5. And this strip is decelerating. Okay, what's the question? What's the speed just before it strikes the ceiling? What kind of a speed is that, kinematically speaking? Initial or final? Final. All right. So for part A, everyone, for part A, VI is 9.5. Delta D is also positive 3.6. And acceleration is a negative 9.8. And we want VF. What's missing from that equation? Sorry, what's missing from that list? Time again. VF squared. Hey, good news. Everything we need is on the right side. All right. Initial speed is 9.5. By the way, question everyone. Do you expect your final speed to be equal to 9.5, bigger than 9.5, or less than 9.5? Think just why less? Because not necessarily. It's a factor, but what's the direct reason? It will be slower when it reaches the what do you call it, the ceiling level. It is going up, but what does that mean? It's what? Thank you. So the keyword is what? Because it's slowing down. Thank you. All right. 9.5. Oops, I forgot the square. Don't do that. 2, negative 9.8, 3.6. All right. Let's get the whole thing done in one shot. I can do this part first on the calculator right here. So I'm going to multiply. Obviously, I know positive times a negative is a negative. So 2 times 9.8 times 3.6, 70, 56. 70, 56 with a minus. So I need 9.5 squared. Well, that's 90.25. And then that's it. So 9.5 squared minus, how much? 70, 56. Does that answer make sense? Sorry, is that the final answer, I mean? First of all, no way, because we haven't square rooted. Also, what did we say our final speed has to be? More or less than 9.5? That number is still bigger than 9.5. It needs to be square rooted. So 1969, square root this guy. Obviously, you're going to get 4 point something because it's less than 25. 4.437. Cut it right here. It will be 4.4. Yep, 4.4 meters per second. So apparently, did it come to a stop before it touched the ceiling, or did the ceiling actually stop it? The ceiling stopped it because apparently it was still in motion right at the ceiling level, going up. Okay, question B. How much time from when it leaves your hand does it take the body to reach the ceiling? Okay, redo the problem, but this time not with VF as an unknown, with delta time. All right, B. So now calculate, calculate delta T. So what is missing from the list? You see, I didn't rewrite the list. What would be missing from the list now? VF. Which equation has no VF? Equation 3, because it's only concerned with VI. All right, let's do the equation. Delta D, delta D equals VI delta T plus 1 half A delta T squared. Oh, crap. We're going to do another what? Quadratic. You know what? Fine. At least let's do it this time. All right. What's delta D? 3.6. Come on, come on. 3.6. VI. What's VI? What was it? 9.5. Yes. 9.5 delta T plus. Well, it's a plus times a minus. That's fine. So it's going to end up being negative. Negative 9.8 delta T squared. Okay. Okay, everyone. My next step, I'm going to do two things at once. Look, everyone, just for 10 seconds. I'm going to multiply and start what? Start what? Moving or rearranging, as Nora said. So obviously, what's plus times a minus? Minus. When you move it, it becomes what? Positive. What's half of 9.8? 4.9. So 4.9 delta T squared. How about this one when it moves? When it moves? Negative. Negative 9.5 delta T. Did we touch this one? Nope. Plus 3.6. Equals what? Okay. What's the quadratic formula again? It's this guy. So, but instead of x, what's my variable now? Delta t or t. That's fine. So delta t equal. Oh, what's my a? Everyone, what's my a value? What? Okay, everyone, go ahead. Write a here. Okay, what's my b? Yes. What? Everyone, most common mistake, especially for the b and the c. People only choose the what? The number, not with the what? You have got, if it's negative, B is negative. If this one's negative, C is negative as well. So B is this guy, including the negative, and C is this guy. All right, so equal. Big fraction. Bad. Okay. What's my first term? Minus what? Minus B. What would minus B be? Yep, it's negative, so it has to be negated, so it's positive. So everyone go ahead, just 9.5. Again? Plus minus. Long square root. Long square root. What has to go here? Everyone, at the beginning. Negative 9.5 squared, which is going to end up being what? Positive. So that would be the 90.2. No, sorry. Yes, yes, sorry. 90.25. 90.25 minus 4 times what? 4 times A, which is 449, times what? Times 3.6. All dividing 2 times. Go ahead, Josh. Oh, I squared the 9.5. 9.5 squared. All right. I'm going to try to clean this up and square root it in the same step. It's just numerical stuff now. So let's do this. What do? We have 4 times 4.9 times 3.6. 4 times 4.9 times 3.6. This needs to be negative. So negative plus 90.25 square rooted 4.44 divided by what? Again? 9.8. That's double to 2.49. Okay. So we get what? We get 2 times. We get, let's just do the plus first. Doesn't matter which one you do first. You have to do both. So 9.5. So 9.5 plus 4.44 divided by 9.8, which is how much? 1.42. So 1.42 seconds, bless you. And 9.5 subtract 4.44 divided by 9.8, which is 0.516. 0.516 seconds. Yes, Josh. Exactly. Which time do we choose? Okay. 1 second, everyone. Let's look at the diagram. By the way, I'm gonna stop here. Let's look at the diagram. Okay. So, everyone, imagine if the ceiling was not there. Everyone, eyes on the screen. Imagine if the ceiling was not there. Would it hit something? Everyone, pencils down. Let's just think of it. No hitting, which means would it stop at the ceiling or keep going? And then what? And then stop, and then? So that level of the ceiling right there, would it reach it once or twice? That's why you had how many times? 2. You see, math does not care about the physics. Math does not care if the ceiling is there or what or not. Was that what you wanted to say? Amar, you had your head. Say again? So, 2 times, by the way, those 2 times are both what? Are they both correct? If the ceiling wasn't there. So apparently, if the ceiling wasn't there, it would reach 3.6 meters after how much time? The lesser time. And then it would reach it again after what? After this time, right? So which time do we take? The earlier or the later time? The earlier time, because that's when it actually what hit the ceiling for the first time. Awesome. Do you see now how they do university problems? Do you see now how I do them with you? By the way, no problems like this exist in Nelson. Why would I do Nelson with you then? Definitely do the ones that you're gonna see next year and actually explain what we just did. So everyone write what? Let's write the therefore statement real quick here. I hope you have enough space. I don't. So I'm just gonna write it just here. So let's say since everyone since I don't want to say it hits the ceiling twice. It doesn't, but it reaches the ceiling level twice. Since it reaches the ceiling level twice, we take, I don't want to say smaller time, let's call it earlier time, because that's exactly what it is. We take earlier in quotation marks, earlier time, which was how much? 0.5516 seconds. 516 seconds. Done. That's it.